Tonight's teardown is assisted by Roundabout English Dark Mild Ale from Torque Brewing in Winnipeg. They describe it as reserved, nutty, bespoke, and malt forward. And I can't disagree with any of that. It's very nice beer. So tonight I've got a Vintage Tech teardown, and I might have to adjust a little bit here just to make it fit on the workbench. Yeah, that's not gonna work. Hang on. Okay, that's a little bit better. It's still kind of awkward though. This is an Ericsson RBS 882 cellular base station transceiver. This is from the, well, what does it say here? This one's manufactured date is 1996, 43rd week. So this is not 5G, not 4G, not 3G, not 2G. This is back before they'd invented Gs. This is an analog cellular radio. And this that's sitting here is one voice channel. It's massive and it's huge. And I remember the first several years of my career in telecom replacing these beasts and hauling them around. They weigh about 35 or 40 pounds. It's a big one. So just quickly go through the connections on the front before I go too much farther. There is the transmit cable, which goes out to some combiners and then up to the antenna. That's 50 watts. An RF test port for calibration and alignment. Skip over here. There's two receive connections. These are diversity receivers, so there's two full receivers in here, and it decides which one is the better signal of the two and uses that one. It keeps switching back and forth. We have 24 volt DC power coming in here. And then these connectors here, there's three connectors here that Ericsson used to call a quarter plug. So one would go there, one would go there, one would go there, and then 1, 2, 3, 4 over here potentially. This one is the audio line in, just 600 ohm, 0 to minus 6 dBm audio. One pair for input, one pair for output, and I can't remember what the other two are. I think they're shield grounds. And then two quarter plugs or a half plug for a test box, which breaks out a lot of the analog signals inside it for when you're doing calibration and alignment. Over here we have one quarter plug position for alarm outputs. So if this thing's unhappy or in trouble, it will send a flag out to the system. MD link, that is a data control link. I can't remember what the M stands for, but that goes to a control rack that's also in the same shelter at the base of the tower. Local control is a serial port to your laptop so that you can take control of it and run it through its paces for testing and alignment. And then address code, there is just a strapping plug that plugs in there, and jumpers pins together in a binary way to tell this thing what its address is in the local system. I believe it was 0 to 63 addresses. A couple of them were reserved, but so you could have 62, I think, voice channels in one installation before you had to go to a second control rack. And then we got some status LEDs and stuff here. We have a transmit oscillator frequency adjustment. This one's still got a cap on it, so nobody since the factory has had to adjust this particular one. PA transmit level, receiver squelch, the receive audio level, transmit audio level, and a loop gain, which is there's an internal audio loop. When this thing is setting up a call at the beginning, it sends that loop back, so at the switching station it sends audio out, bounces it off, or tells this thing to go into loop back, sends it back to make sure that it's present and it's got a path before it even tries to set up. That way you don't have a call with no audio on it. And then some Then we've got some LEDs, transmitter on, carrier presence, 5 volts, communication, and a couple of status LEDs. And that's it on the front here. On this little card in here, which gives you the revision levels of all the different sub-modules inside it and whatnot. So there is the side of the thing. The majority of it is in this part of the box here, and then back here is the RF power amplifier. And over in the corner, I'll try to do this without spilling my beer, there is a cooling fan on the transmitter. All the connections happen on the front, and this just slides into a rack. So typically there would be maximum 8 of these radios in one cabinet. So you'd have a cabinet there with 4 radios in the top, 4 radios in the bottom, and 2 4-channel RF combiners. And then at the top there would be receive, LNE, and distribution and stuff. So these bottom 4 radios, their transmitters would go into the bottom combiner, top 4 into there, and these 2 combiners would go out to a non-frequency selective combiner here, which is actually got 4 ports on it, and that would go up to the antenna. And then if you had a second cabinet beside it, same configuration, that would put out the others. So there we have 16 radios on 1 transmit antenna, and then 2 receive antennas coming in here into the preamplifiers, and there's jumpers across that go in, and then that splits out, preamplifies, and goes to all the radios. You could, off a common control rack, have, typically you'd have this multiplied by 3, because most cell sites have 3 sets of antennas up top, 2 transmit or 2 receives and 1 transmit, times 3, facing in, looking from the top down, facing in 3 different azimuths. So in that case you could have 3 pairs of cabinets. So that's the basics of how this works. And this is actually the Ericsson's 2nd generation of 1G or 1st-G analog cellular. The original ones, the RBS 880, only had 4 radios per cabinet, 1 combiner, which was, for whatever reason, mounted on the floor of the cabinet with, and it was a pain in the ass to tune. But anyway, I digress. And then the rest of it was sort of logically laid out the same. But this was the ones that were being installed when I started in this career. And then this was superseded by GSM, which was superseded by LTE, which is superseded by UMTS or HSPA. No, wait. GSM, UMTS, then LTE, and now 5G. Because they've decided to stop giving them names and just give them Gs for whatever reason. Anyway, that's where this is. And so this radio would be in one of these positions. And as I said, these are analog. In the same form factor, a few years later, they started doing a digital radio, which could have 3 voice channels in the same size box, which would just slot into the same cabinet and use most of the same control electronics. Not entirely, but that's outside the scope of this. If I get my hands on one, I'll bring it in. So this RF power amplifier section in the back here is attached with a connector and a couple of bolts. There's one there and one on the other side. So I think I'm going to undo those just to separate this down and make it a little bit more manageable on a workbench, because right now this is just ridiculous. Okay, so after unplugging this control and power connector, this RF connection and this RF connection, interesting that they're 2 different ones. It's an SMA, and that's SMB, I think, TNC? No, it's SMB. So I'm not sure how much detail I'm going to be able to glean out of this without any schematics or anything. As I said, we never went inside these things. We just send them back to the manufacturer for repair. But this cable is the transmit output. So that's got the 50 watts amplified on it, which means these 2 funky little transistors here, RF transistors, high frequency stuff, are going to be creating the 50 watt output. What is that, 100 ohm resistor right there. Fairly normal little electrolytics, okay. Some surface mount stuff, a little inductor there. And this, I'm going to guess, is coming back over here for DC bias or DC measurement or something like that, quite possibly. Anyway, yeah, you can see RF circuitry always gets a little weird, and the higher the frequencies go, the weirder it gets. This was in the 800 to 850 megahertz range, so it's not even all that weird yet, but still, we got some little tuning inductors etched right onto the board there. What's that? That's another 100 ohm resistor there. Odd packages, but the flat leads on them, you can see these two 100 ohm resistors here look like they are going onto this little strip line. What's that dot doing there? I don't know. Anyway, that combines into there and into there and onto there and out. Right. And those look like they're being driven by this transistor here. Beryllium oxide, danger, poison, do not eat. Right. How often do you see a resistor with a heatsink? What's hiding underneath? There's a little flat transistor under there. You can see the 4 leads coming out. I'm not sure why 4, but there's coming in. So that side's presumably the base of it. And it looks like going out there, so that's probably collector going up that way into this guy, shoot across into this guy, and then out to these two beasts over here. And again, those are going to be just probably power coming in various places. There's a little feed through this shield here, actually 3 feed throughs separating what I assume over here is the power supply board, power supply and control board. Although there is an LM7808 there, which is going to be an 8-volt voltage regulator. Okay. A couple little pots for adjusting there. And what do we have over here? I don't recognize any of these. TIP36A is these two bigger ones. TIP36A is a PNP high power transistor, 25 amps, 60 to 100 volts, 125 watts. And there are 2 of them in there. Wowzers. Yeah, that probably is a power supply section. And then these little coaxial feed throughs just to sort of keep the RF in its own lane, basically. What's that? That goes to another feed through onto the other side, which, goes over to the fan. Okay. So that's the fan power. Right. At least I'll be able to salvage 24-volt fan out of this. I don't know how much else I'm going to be able to salvage. Okay, let's see what's under there. If we can get it out. There we go. It's a single-sided board. The back side is entirely just shielding. Little package there. TO220 package. Didn't expect that. That is interesting, though. See that little TO220 package there? It's soldered flat onto this side of the board and facing through a cutout. Where is it? There it is there. And some heatsink goop on the back side of it, holding it down to the heatsink. Huh. I have not encountered that before. And then you can see the heat sinks on everything else coming through the board and meeting up with this big honking heat sink here that has a fan blowing across it. And again, I don't pretend to know an awful lot about the circuitry at these high frequency RF here, but I do know that any of these ceramic bodied transistors with the flat leads on them are going to be RF high frequency transistors, and they're going to be frickin' expensive and pretty specialized things. Hadn't noticed that before. See this guy here, and there's another one over here. The little nylock nut on it. If I'm not mistaken, that is a variable capacitor. Correct me in the comments, but I think that's what that and that one over there are. Wow. RF is weird shit. My hat's off to the engineers who actually designed this stuff. Right, onwards to the other half of this box. Now that it's actually small enough to fit on the workbench. So here is the output, the 50 amp or 50 watt output coming from that PA module. Goes through this little can here, which is just shielding and stuff. Oh wow. There it comes in there, and you see this weird little set of interlocking pads there and there. Is that inductive coupling? I think, because that just comes straight through to here. I think that is inductive coupling off to these pads here, which I'm pretty sure go down to this cable here, which leads to the test port on the front. So you can just get a sniff of the RF for monitoring for frequency tuning and stuff like that, modulation tuning. Now then, this is the output to the power amplifier. So this is, oh, who knows, but there's two of them. The part number on the board is slightly different, so I'm not sure exactly what's going on them. But they both look like they've got, what are you? I don't know, there's tuned RF componentry on there anyway, which is what these two variable inductors, that little fixed inductor, and I wonder if, let's see what's underneath them, because there is weirdness going on. I just want to see. Okay, so most of the magic's going on hidden inside that little can there. That'll be the higher frequency stuff, higher sensitivity to external interference and whatnot. The board design itself is 1994, even though the rest of it was 1986. Those two Phillips chips are the same. That one and that one are the same. That one and that one are the same. The only differences are down here. There's a few more components. And it looks like it is actually almost the same board itself, just populated differently. Yeah, the board itself is the same. Okay. They've just been populated differently. So these are both, I'm going to guess, intermediate amplifiers. But I didn't see how the signal got from one to the other. And actually it doesn't. Yeah, this one was clearly in the signal path going out to the power amplifier. So that I would guess is a preamplifier. I really don't know what this guy was doing. Although he was measuring some, it looked like it had something going on over to there. So I don't know. I'm just exploring and having fun here and satisfying my curiosity. If Dave Jones can make guesses, so can I. So down here, this is, looks like, what are we connected to? This has the control signals coming in, the address code and stuff. So that's going to be the processing and stuff down there. Over here is going to be, well, it has these two lines are the receive lines coming into it. So that will be receive amplifiers. And the audio is also coming onto the analog input. The analog audio is also coming in here, and it's also got the test signals. So RF demodulation for the receive side, and maybe modulation, or maybe that's what was happening on one of these boards. I don't know exactly. Should we yoink the rest of these guys out just for completeness and fun and games? I think so. Haha! See this blue dude back here? That looks like a DC to DC converter. Matter of fact, I'm almost certain of it. That is exactly what it is. It is a DC to DC converter. 1996 vintage. Input between 19 and 35 volts. So the 24 volts that this thing's getting is perfect. Output 5 to 15. So there's 5 volts. There's a plus and minus 15 volts. There is the input coming through these two ferrites. Ferrite on the output as well. An auxiliary which is not used. A couple of non-connection. So if I put 24 volts into this thing, I should be able to get some voltage. And it is good for 25 watts. Okay, well that's a keeper. If nothing else, well, that and the fan. That's definitely keepers. So most of the receive and low noise amplifiers and demodulation is going on hidden in these cans with all these secrets. Oh, got 2 crystals over there in that can. You see them there. So there's 2 oscillators in there. Filters, there's a few of these guys here. Which again, I don't know what those are. Maybe some kind of filtering, maybe some kind of amplification. I don't know. Weirdness though. Yeah, there's a lot of bespoke components and very specialized stuff in here. So for all the specialized stuff in here, there's also some just really standard generic stuff. 74HC138, that is 3 to 8 line decoder demultiplexer, just bog standard CMOS logic. LM317, isn't that a regulator? I'm not used to that being in a dip package. Alongside of all this funky RF stuff, then you find something like that. A neat little inductor there. I'm going to pull the rest of these boards out and we'll just take a quick peek at the backside and see if there's anything surprising or interesting back there. This board here has a few chokes on it and a whole bunch of capacitors. Oh, 7812 regulator. Okay. NE5532. That is an op amp, and there's 3 more of them over there. So this one, this board has some of the adjustments on it. The squelch on the receive side, the receive audio, that loop audio that I was talking about in the transmit audio. Yeah, there's a ton of capacitors on this board. Then there's some factory adjustments back there that are not labeled. There's no way I'm going to find a schematic for this thing. It was just too proprietary. This one has DC input, the audio line, and a couple of test ports. So there's a bunch of DC voltages and whatnot. Were there also the audio on there? Possibly. And AGC and all kinds of stuff like that on here. And then the frequency adjustment for the transmitter and the transmit level. So again, those are going to be just, I'm guessing, DC voltages back to VCA, VCO kind of stuff. Nothing on the back except for ground plane. And I don't see a whole bunch of traces coming in and out of here. Oh, this is going to be a multi-layer board, isn't it? Sure. So there's going to be no way to tell where those are all going. And one thing I've noticed on this board, as opposed to a lot of boards, is there are no component designators anywhere telling you what's going on. See that? So they were not expecting somebody to figure this thing out unless they had a full manual and set of schematics. Which is a little disappointing because it makes it hard to reverse engineer just from a curiosity. Another surprising thing, or another interesting thing, the modern Ericsson stuff has a lot of their own branded silicon in it. This one has a well, it has some ST parts, but it's got a lot of Philips branded parts, like this SA604. There's a bunch of those inside these various RF cans. And I guess this makes sense. SA604 is a high-performance, low-power, frequency-modulated IF system. 2 intermediate frequency amplifiers, quadrature detection, muting, receive signal indicator, and voltage regulator. Wow, that's a busy little chip. And there's a bunch of them on this board. But yeah, it can be used for all kinds of stuff. RF level meters, communication receivers, which is exactly where we're seeing this inside those cans on the receive side. Makes perfect sense. But wait, there's more. I didn't explore the back side of this guy, and I noticed on the other side that there is a connector coming through that I didn't explore. So let's dig in here. Oh, hello. This would be the digital control board. Judging by these higher density chips on here. Right, let me yoink this board out and see what we can find. Remember on the other side how I was a bit surprised that there was no Ericsson silicon and lots of Philips and some ST. Well, this one's got Harris, it's got Motorola all over it. And a Motorola 6809. That's definitely processing. Intel 8052. Intel 8052. Wow, lots of brain boxery going on in here. Aha, and what looks like a PROM, a custom PROM. That's an Ericsson format part number. So the 80C52 is an 8-bit microcontroller. And what did we find? 2 of those on there? And the Motorola 6809 is an 8-bit microprocessor. So it's going to be in charge of everything, and the microcontrollers will be doing its bidding, I'm guessing. Anyway, that is the plug that's got the address on it. It's got the controls coming from the rest of the system and the alarm and the address code and local serial port on it. Serial port is this section right here. 1993 copyright date on the board itself. Well, I had fun with that. I hope it was an interesting exploration for you too. There's a lot of questions unanswered in here. I kind of expected that just based on what it is and how proprietary it is. But it was kind of fun for me after, schlepping these things around for a decade or more, getting to see what's inside it for a change. Hope you found that interesting. Questions and comments down below in the comment section as usual. I tried to find some links to this stuff, but it is so obsolete that there's pretty much nothing available. The more modern Ericsson radio equipment is available. There's information available online, but nothing for this old stuff or the previous generation. I don't know. I might see if I can get my hands on the next generation beyond this. As I said, this was analog. Then in this same generation of hardware, same packaging, came a digital radio. And then the same RF standards, they came along with a third generation of the hardware that Ericsson called RBS 884. And I might be able to get my hands on that. The radios are about a quarter the size of this one and can do the same job as this, or can do the digital 3 voice channels per RF channel job that this thing's brother could do. I don't know if anybody's interested, and if I can find some in a neglected corner somewhere, maybe I'll bring one in and play with it. Anyway, thanks again for watching. I will talk to you later.